here because I don't know, that you can always kind of use this standard set, but doesn't always work out great. So from here, you have to evaluate the function at each of these points. Would you try evaluating this function at x equals 1?
Okay. 8.
3 times 1 squared minus 1.
Oh, yeah, 8.
8. So you're squaring 1. What is 1 squared?
Oh, I thought I was squaring 3 times 1.
Yeah,
1.
and then times 3 is 3, minus 1 is
2.
2. Okay. Now, watch this. So 3 times negative 1 squared minus 1. Negative 1 squared is 1. 3 times 1 is 3, minus 1 is 2. You see how those are the same?
Yeah.
And that's kind of common here. All right, now can you try 2? Put 2 in for x and tell me what you come up with?
Okay. $11.
It is 11. Now at negative 2, it's really important to put it in parentheses. Negative 2 squared is
11.
11 again. Yeah. Now there's this symmetry. There's always this symmetry. Okay, so if you get the vertex and you go left of it, right of it, you get the symmetry of the numbers.
Uh-huh.
Okay, so we're going to graph these points there. So negative 1, 2, it's like there. I'm sorry, 0. I should have done that one for 0, negative 1, 1, 2, and then 2, 11. We really don't have, and you can kind of estimate it up here if you want, but the graph looks something like this.
Okay.
Any questions on that?
No.
All right. So for the one on the right, it's a little bit different. Number 20 there. This is in vertex form. Do you remember that at all from class or?
Yeah.
So the vertex here it comes from what's inside parentheses. It's always opposite of what you see in there. So instead of it being +4, it ends up being -4 is your vertex, your x coordinate. Does that sound familiar to you? Something you've seen?
No.
Okay, yeah, I was worried about that. So we're just going to go with it. -3, -2. Sorry, I'm going the wrong direction. -5, -6, -3, -2. So what I'd like you to do is put -4 in for x in this parentheses here. And give me a number for that.
1/2.
It is 1/2. Yeah. Well, hang on.
Oh,
It
it's
is.
0,
It's
0.
yeah. It's 1/2 times 0, which is 0. Good. Good catch. How about the next one here? -5.
Oh, 1/2.
It is 1/2. Now, that's kind of a problem, but we'll get to that in a moment. How about -3? What do you expect to get for -3?
Bro, 1/2.
1/2. Okay. Now, I don't really like graphing fractions, so we're going to do something in a moment. Try -6 or -2.
Um, 2.
So it's -2 + 4 squared. That's 2 squared, that's 4, but then you take a half of it, which is 2. Yes, okay. What about -6, or maybe you did that?
Yeah, I did that.
Okay, so whenever you get fractions, here's what I like to do. I actually eliminate them, get rid of them altogether. And I mean, I have the kind of advantage here being able to do this. And I look for like a pattern. I'm like, oh, if I go by 2, I get nice numbers. So why don't I go by 2 again on each side and see if I get some nice numbers?
Okay.
I think you will see that you will.
8.
Okay, an 8. And that makes it easier to graph.
Do I graph it?
Let's go ahead and graph those points. Probably good to start at the vertex there. I'm going to do it in a different color here. -4, 0, -6, 2, -2, 2. You can't draw the 0, 8. So you can kind of, estimate it up there. I don't know, something like that. Any questions on that before we move on to number 21?
No.
Okay. The 21 through 26, I think, are pretty tough for most new algebra students. It's really challenging to remember all the exponent rules. And it's also kind of frustrating to like, well, when do you stop? How do you know when you're done? Could you just confirm that? Is that x to the 5th or 3 above that?
It's x to 0.
That's a 0 there?
Yeah.
Oh, okay, I'm
It looks
surprised.
like a 3 on that, but on the paper it's a 0.
Yeah, okay, good to know. That does. So there's all these rules. Okay, there's all these rules. I mean, you've seen them, but it's been a while. So one of the big ones is that if you have a negative exponent, you rewrite it as a positive exponent on the bottom. And then similarly, if you have a negative exponent on the bottom, it becomes a positive exponent on the top. And so those apply to the 2 to the -3 and the y to the -4. Basically, the 2 to the 3 goes to the bottom and the y to the 4 goes to the top. They switch positions. Is that, I mean, do you remember that, seeing that?
No.
Okay. Yeah, we might have to spend a little bit more time here working on some exponent stuff, especially if you're like, yeah, I haven't seen this in a while.
Yeah.
How about to the 0 power? Do you remember what that becomes? Anything to the 0 power?
Itself.
It's just 1. It's just 1. So that x to the 0 becomes a 1. Is that okay?
Yeah.
All right. So we need to look at these two rules. We need to do a couple more problems like this. So I'm going to attempt to do that now. So let's say it's a to the -2, b to the -3. This becomes b cubed over a squared. Basically, the exponents flip positions. Okay.
Okay.
But here's another possibility. Another possibility is I give you something like this: x to the -4, y to the -5. This becomes, and I'm gonna show it vertically here. If you kind of look at these separately, the first one becomes 1 over x to the 4, and the second one becomes 1 over y to the 5. So on top it's 1 because it's 1 times 1, and then these stay on the bottom.
Okay.
Here's another example, something you might see. Let's say it's a 2x to the minus 8.
Yeah,
So this is really 2 times 1 over x to the 8th, which becomes 2 over x to the 8th like this.
okay.
So I think we have enough to do 26 next. I think kind of there's enough understanding of that. Might need to double check here what the exponents are. Is that minus c to the minus 7 and b to the what power?
The 6th.
6th. Good. Okay. So what can you do here? This is kind of like the last few that we've been doing. A little bit different, but
Um, hmm, um, I don't know.
okay, well, what did we do in the previous problem?
We like simplified it.
Okay, but give me some different words. I never actually used the word simplify. So like what's different between what's here and then what's below it?
The one below it is a fraction
Why did I make it a fraction?
to make it positive.
That's right. Do you have a negative exponent here?
Oh, so you should multiply everything by a negative, right?
I didn't do that. And that's not what you said here. You said flip it, make it positive, right? You said I'm going to make it positive. That's fine. I'm asking you, the only change you have to make is this to the c to the minus 7. That's the only change you have to make. What's
Oh,
another way to write c to the minus 7?
um, C um over 7.
Okay, so let's go back up and look here. What did x to the minus 8 become?
1 over x.
Okay. What did x to the minus 4 become?
Uh, 1 over x minus 4
There's no negative down here.
over x to the 4th.
Right. How about y to the minus 5th? What did it become?
X to the 5th.
Y to the 5th.
Oh
So
yeah.
notice it's the same letter. The number is now positive with a 1 up top. Same thing here. Y, same letter, minus 5 goes to positive 5. Yes, no, maybe.
Here.
Okay. So I'm not giving you anything different here. I'm just giving you c to the minus 7.
So it's C to the 7th, 1 over C to the 7th.
Yes, yes, good. So this is 12 times 1 over c to the 7th times d to the 6th.
So
How
it's
can you simplify this?
12 over C to the 7th times D to the 6th.
Yes. Like this. Okay, let's try another one here. Let's say it's 2x to the 9th, y to the minus 7. What does this become?
Um, um, 2x to the 9th over y to the 7th.
Good. That's really good. The other type of problem we were looking at is something like this, like 3 over x to the minus 4. So when the variable on the bottom is negative, or the exponent on the bottom is negative, you move it to the top. This becomes 3 times x to the 4th.
Okay.
How about 4 over y to the minus 8? What does that become?
4y to the 8th.
Very good. Okay. So let me just make up one here for you. Let's say it's a 12x to the minus 5th over 5y to the minus 7. what would this become?
Um, 12x to the fifth. Times 5y to the seventh.
What goes on the top?
5y to the seventh.
Okay, so the numbers do not change positions because there's no negative exponents there. It's just the variables that you have to worry about.
Okay.
They switch positions.
12y to the negative to the seventh.
Yes, 12y to the seventh over.
5 to the fifth.
Yes, good. All right, really good. 22, what is the exponent above the 3?
0.
Okay, can you tell me what 22 becomes?
1.
It becomes 1, good. Okay, so before we can do 23, we need to just quickly talk about some rules. We were doing this the other day. Why is x times x equal to x squared? You remember from the other day you were doing this, you were doing it right. Just asking here if you know the reasoning behind it.
Because that's what happens when you square something.
There's actually 2 exponents here for each of them, right? And it's not that it's 2, it's that it's 1 plus 1, which equals 2. Okay, like if I asked you what x times x to the fifth is, well, it's really x to the 1 plus 5, which is x to the sixth. So when the bases are the same, okay, you add the exponents.
Mm.
This might go on your reference sheet or something like that. All right. So
Yeah.
let's look at number 23. Is that 5 to the minus 6 times 5 to the third?
Yeah.
Okay, so the bases are the same. Bases are the same, so you have to add the exponents. What does this become?
5 to the negative third.
5 to the negative third. Now, it works the same way for numbers as it does variables, which becomes 1 over 5 to the third power.
Okay.
Can you tell me what 5 times 5 times 5 is?
15.
Nope. 5 times 5 times 5. You gave me 3
Uh,
times 5.
125.
Yes, so this is 1 over 125. Very good. Let's try another one like this. Let's say it's a 2 to the minus 7 times 2 to the fourth. I want you to try working this out, please.
Okay. Uh, 8.
Is 8 your final answer?
Yeah.
Okay. 8 is not correct. So tell me what you did here, because it sounds like you just rushed through it. It's not about getting the answer fast, it's about getting it right. What do we do to the exponents?
You add them.
Okay, negative 7 plus 4, what does that become?
3. Negative 3.
Negative 3. That's very different than positive 3.
Yeah.
What does this become?
Negative 8.
What did we do in the previous problem?
1 over 8.
1 over 2 to the power 3, which is 1 over 8. So everything you gave me was, everything you did here was correct. You're making all the classic mistakes. And again, keep in mind, I'm putting a problem up just like the one you're doing. Like I'm not trying to give you any tricks. I'm not trying to make it impossible here. So let's do another one here. Let's see if you can do this one correctly here. Minus 9 times 3 to the fifth power. Go ahead and try this one for me, please.
1/3 to the negative fourth.
So notice we didn't have any negative exponents in the bottom
Oh,
before.
to the fourth, to the fourth.
Okay, so it's 1/3 to the fourth. What does that become? What is 3 times 3 times 3 times 3? 4 threes, multiplying 3 4 times.
Um. Um. 27 times 3.
Okay. You can also multiply 3 times 3, 3 times 3, so 9 times 9. It's another possibility.
81.
Okay, so this is 1/81. All right, questions on that? Do you feel like you understand it?
Yeah. I got. Yeah, I
All
got
right,
it.
all right.
Yeah.
Let's look at the next problem here, 24. It kind of is, it's a totally different property, so kind of unrelated to what we've been doing. But just to confirm, this is -4x² to the power of 3. Is that
Yeah.
what you see? Okay.
Yeah.
So really what's going on here, and this is, I wish you didn't have a negative because I think this would be easier. This is really -4 to the power of 1, x², all to the power of 3. And the reason I write it that way is because you distribute the 3 to each of these exponents. And that may have been what you were thinking about in a few earlier problems. When you have an exponent to an exponent, you multiply. This becomes x to the n times m. So in here, it's x to the 6th power. You take 2 and multiply it by 3. Similarly, it's -4 to the power of 3, 1 times 3. Okay, so you distribute that number there. All right.
Okay.
Can you, and be very careful how you answer me this, because it's really important that you work it out by hand. What is -4 to the power of 3? Basically, it's -4 times -4 times -4.
Um. -64.
It's -64. Good. Okay, let's do another one like this. I'm gonna leave this one up here. Let's go -3 x to the 4th cubed. Okay, it's just like the last one, just different numbers. Please give this a try.
Um. -3x to the 12th.
Okay, I mean, here's what you just told me. Is that you really feel confident about that answer?
Yeah.
So when we look back at the previous problem, the answer did not have the original number in it.
I guess. 27 to x to the 12th.
Okay. These are all answers that I would include on the multiple choice, and they're all wrong. So again, I don't get the impression you're working it out the way I've done up here. It's -3 to the power of 1, x to the 4th to the power of 3. If you work it out this way, and it's really important to do that, especially because of the signs, the negative signs, and then you distribute the exponent here, it becomes -3 to the power of 3, x to the power of 12. -3 times -3 times -3 is -27. And in math, it's the difference between positive and negative is like in swimming, it would be like, backstroke versus freestyle. It's just totally different. Like in math, you could say, well, it's just a negative, but it's huge. It's a huge difference. It's a really a big deal. All right, let's keep this problem up here. Let's try another one here. Let's try -5 x to the 4th squared. This one's a tiny bit different, but if you use the same steps, you will get the right answer if you just follow the same procedure.
-25 x to the 8th.
Okay, so again, pretty close here. -5 to the power 1, x to the 4th squared. When you distribute that 2 there, it's -5 to the power of 2, x to the 8th. -5 times -5 is +25. What do you think is unclear? I mean, what we've done a couple now in a row. What do you think is causing you some challenges on this?
Negatives.
The negatives?
Yeah.
Are you writing it out the way I'm writing it out with power of 1 in parentheses?
Yeah, I just didn't know that when you did the exponents, it wasn't negative.
Well, it depends. So like the reality is if you have -1 to the power of 1, this is -1. -1 to the power of 2 is 1. -1 to the power of 3 is also -1. -1 to the power of 4 is +1. So if the exponent is odd, you get a negative. If it's even, you get a positive. This is a shortcut, but you have to be careful here how you use it because it can be very easy to mess this up. So let's try another problem here. Let's try -4 x squared y to the -3 all to the power of 2. Okay. So I'm just making this up here. -4 to the power of 1 x squared y to the -3 all to the power of 2. So I'm just rewriting that -4 in parentheses with a power of 1 exponent. Really important to do that. And then you multiply each of these by the exponent. So it becomes -4 to the power of 2, x to the power of 4, and y to the -6 power. Can you tell me what this part becomes here? -4 to the power of 2.
-16.
Okay, we just
16,
said if it's
16,
yeah, and
16, 16.
it is 16. Okay, and if you're not sure, you can always work it out. I mean, take your time here. We're not in a rush. X to the 4th, y to the -6. Now, from an earlier problem, how can we rewrite y to the -6?
1 over y to the 6.
Good. And so what does how would you rewrite this? Tell me what goes in the top, what goes in the bottom.
16x to the 4th,
And on the bottom?
y to the 6th.
Good. All right, now look at this problem over because I'd like to give you one like this. Like we rewrote the -4 to the power of 1. We applied this exponent to everything. Then we simplified the number part, and then we moved the negative exponent to the bottom. Is there anything here that you don't feel like you understand or could replicate if I give you one kind of like this?
Not really.
Okay. All right, so let's try this here. Let's try -3 x to the -4 y squared to the power of 2. So go ahead and give this one a try, please.
Okay. Y to the 2nd over 9x to the 8th.
Like this?
Yeah.
Okay, close. Why did you put the 9 on the bottom? What made you say, okay, I got to put the 9 down below?
Because it's next to the X.
So they're really separated. It's really like -3 to the 1, x to the -4, and then y squared. And then you're squaring each of those, but they're kind of all separate entities once you do that. All right, so it's like -3 squared, x to the -8, y to the 4th. You treat them all separately, like just because x is going down to the bottom doesn't have anything to do with the y or the number. Because based on what you said, it would be like, oh, well, y could also go to the bottom because it's next to the x. It's like, no, they're separate. They're completely separate. It's like swimming lanes. So the 9 actually goes to the top or stays in the top. It's 9. -3 squared is 9. This is 1 over x to the -8 is 1 over x to the 8th, and y to the 4th stays up top there.
Okay.
All right. I know this is probably really painful. I got to get you to one. We got to get one more here. Let's try -4 x to the 7th, y to the -3 to the power of 2.
16x to the 14th over y to the 6th.
Yes, very good. All right. So good job on that. We are going to skip that one. There's another problem there that's going to it's going to create a lot of confusion if we do it tonight. So we'll let that kind of sink in. We're going to move to just a different part of your review here. So we're kind of doing some sequence stuff the other night. I don't know. These last few here are tough to see. Let me see if I can rotate this. Nope. Let me download. Are you guys doing review in class?
Sometimes.
Are you guys learning new stuff?
Yeah,
Okay.
we're learning about averages.
Yes, they sometimes throw in a statistics unit right at the end of the classes. It's like, no, we don't need to learn anything new. Okay, let's look at 42. Quadratic equations. We got some time here to tackle a new subject here. There's a couple things here. Standard form. Standard form means it's in what's called descending order. Okay, that means that you have the x squared first, then the x term, and then the constant term. Okay, so like for example here, it's x squared minus 7x plus 5. X squared minus 7x plus 5. So that is standard form. You have to know how to write it this way in descending order. All right.
Mhm.
Now the degree is the highest exponent. What's the highest exponent that you see here?
2.
2. Degree of 2. That actually tells you the polynomial type. So, well, I take that back. That is not true. The leading coefficient is the number in front of the leading term. What number is in front of the x squared here that you can't see?
1.
It's a 1. That's a 1. All right, now the polynomial type depends on the number of terms. Okay, so when I say number of terms, 5 is a term. Well, let me do it differently. X squared is a term, minus 7x is a term, and 5 is a term. There are 3 terms. Okay. If you have one term, the name is called a monomial. Monomial. Two terms is a binomial. Do you remember what three terms is called?
Trinomial.
Trinomial. And how about if it's got more than three? Do you remember the name for that?
Polynomial.
Polynomial, yeah. All right, good job. So this is a trinomial. Okay. So I'd like you to try 43 on your own and let me know the degree, the leading coefficient, and the polynomial type.
Okay. The degree is 4.
I agree.
The leading coefficient is -7.
Okay, sounds good.
And
Keep going.
it's a monomial.
Monomial, good. So we like those problems. You'd like to have more of those for sure on the test. Any questions on that?
No.
All right. So let's look at 44 next.
Okay.
44 is 2b cubed minus 5b in parentheses minus 7b plus 3b squared in parentheses, like that. Okay. Now you notice there's parentheses around both of these. So you only need parentheses in two situations. One is when you have a negative, and the other is when you have a number in front. Okay, now this one has a negative here, and that means you distribute that negative to everything inside. You basically change the signs. All right, so this becomes minus 7b minus 3b squared. Is that okay?
Yeah.
Now on the left here, there's nothing outside the parentheses. Like there's no number and there's no negative. That means you don't need them. You can just bring down what's inside parentheses.
Okay.
Do you see any like terms?
Yeah.
What do you see here? What can you combine?
-3b squared and 2b squared.
You got a cubed and a squared. Those don't go together, but the b to the single power do.
Okay. Then those
So
go
that
together.
they go together minus 12b
Yeah.
minus 3b squared, like that. All right, so by comparison, 45 is actually much easier than 44. There's nothing outside the parentheses. You can just drop the parentheses and then combine like terms. Why don't you give this one a try, please?
Okay. 2x squared plus 5.
I'm close here. It's minus 5x squared plus 3x squared, right? Got minus 5 plus 3. So that's negative 2x squared. And then, yeah, the minus 2 plus 7, that becomes plus 5.
Okay.
So keep in mind, like we're practicing for the test. Like it's fine, it's normal, it's okay to make mistakes here because like you really are practicing for something that's coming up. And you know, I want you to get the right answers, obviously, but more importantly is like knowing that, okay, now I get it. I've got to combine the signs like that. Let's try another couple of these here. Let's say give you something that's like negative 3x plus 7 plus 2, 4 minus 2x, okay? So we want to simplify this. And again, when there's a negative, you change the sign. So this becomes minus 3x minus 7. Is that clear?
Yeah.
All right, now on the right here, you multiply 2 into both of these. So this is 8 minus 4x. Could you combine like terms?
Yeah. Negative 7x.
Anything else?
And 1.
Plus 1. Good. Yeah, really good. All right, let's have you try one a little bit more difficult here. Then let's go 4 times 2 minus x minus x plus 3. There's a new one for you to try there at the bottom, please.
Okay. Negative 5x plus 11.
Negative 5x, pretty good. Ooh, so not plus 11. Double check that part, please.
Oh, plus 5.
Yes, very good. Let's try one more here. Negative 3, 5 plus 2x plus x minus 2.
Okay. Negative 5x plus or minus negative 7.
Issue with that again. It is negative 5x. That's good.
Oh, I meant negative 17.
Yeah. Okay. I thought maybe you meant something else because I was surprised that it was off like that. Really good. Really, really good. Okay. Okay. We're going to look at 52 because we don't have a ton of time to kind of do some of the other ones. We'll see what else we can come up with. So, solve the equation. Okay, 52. Solve the equation. So it's x minus 2 times 3x minus 1 equals 0. And the idea here is that if you have 0 times any number, you get 0. 0 times x gives you 0. And these work backwards. Like if you have a number times 0, you get 0, or x times 0, you get 0. And you might wonder, why is he doing all that? Well, either this one is 0, x minus 2 is 0, or 3x minus 1 is 0, or they're both 0. So you just have to solve them to figure out where they're 0 to figure out the value of x.
Okay.
So in this case, it's plus 2 plus 2, x equals 2, plus 1, and then divide by 3. So x is 1/3, x is 2. Have you seen that before?
Yeah.
Okay. So let me give you one real quick. Let me give you an example. Let's say it's x minus 1, 2x minus 3 equals 0. Could you set both of these equal to 0 and let me know what you come up with for X values?
Yeah, I got X equals 1. And X equals 1/2.
Uh,
Negative 1/2.
I got 3/2. Is that maybe what you meant? 1 and 1/2?
Yeah.
Okay, a little bit of a difference there. I mean, you got to be careful. Obviously, writing it is more important than saying it because it's a math class. It's not a, speaking class, but very important to present your answers. So we don't have time for this, but 50 and 51 and 53 are factoring to then solve. So probably pick up there next time and work on that. But we're going to go ahead and stop